Sample 6. Water at 15 degrees Celsius is pumped between reservoirs at the rate of 5.66 liters per second through 120 meters of 50 millimeter diameter pipe and several minor losses due to fittings as shown. Pipe friction loss is expressed as FL over dV times velocity head, and the minor losses as coefficient of minor loss times velocity head. Compute the pump horsepower required, the total equivalent length of pipe, removing all fittings except conditions at entrance and exit, and the percentage of minor losses to the major loss. Friction factor 0.0215. This is the given figure. So to compute the output, horsepower output of the pump, we write energy equation between points A and B first. So call this point A and that one as point B. So we have velocity head at A, pressure head at A, elevation head at A, datum at elevation 0, plus head added by the pump equals velocity head at B, pressure head at B, elevation head at B. Total head loss from A to B, which consists of pipe friction and several minor losses. Velocity head at A is 0, negligible. Pressure head 0, exposed to the atmosphere. Then plus elevation head 6.1 plus head added by the pump equals velocity head at B0, pressure head 0, elevation head 36.6 plus head loss from A to B. The head loss from A to B are all functions of velocity head. So for the pipe, friction factor, length of the pipe over diameter, then plus the different minor losses. Beginning with the entrance, we have 0.5 here, plus 6.5, plus 0.15, plus 0.95, plus 2.7, plus submerged exit 1, all functions of velocity head. So simplifying, head added is 30.5 plus the first term due to major loss is 51.6. Adding this all case here, 12.2 of the velocity head. Next, we compute for the mean velocity of flow, 4 times 0.00566 divided by pi 0.05 square. And that is equal to 2.883 meters per second. Square it divided by 19.62. So the velocity head is 0.4236. Substitute here. So head added is 30.5 plus quantity 51.6 plus 12.2 times 0.4236. So we have head added 57.53 meters. So horsepower output by the pump is Q, weight flow rate Q, specific weight of water, head added by the pump divided by 0.746. We want gamma of water to be 9.81. So 0.00566 times 9.81 times 57.53 divided by 0.746. So horsepower output by the pump is 4.282 horsepower. Next is the total equivalent length of pipe, removing all fittings except conditions at entrance and exit. So if we remove all these fittings here, there is an equivalent length. The pipe is already 120. We add that equivalent length to produce the same head loss. So the formula is KD over F, or summation of K over F. So 120 plus KD over F, where K is the sum of K's is 12.2. We subtract 0.5 and 1 because the conditions at entrance and exit will be the same, so they cannot be removed, only the fittings, so that we can compute this total length. 120 plus 12.2 minus 0.5 minus 1 times velocity head, which is 0.4236, diameter 0.05 divided by friction factor 0.0215. So that total length of pipe should be 144.9 meters, and the head loss in the system will be the same, with or without the fittings. With the fittings, the length must be 120 only, but without the fittings, it should be 144.9 meters. Then finally, the percentage of minor losses to the major loss, percent minor loss would be total K of the minor loss, 12.2 of velocity head, divided by major loss, 51.6 of the velocity head, so cancel velocity head. So it's just 12.2 over 51.6 times 100%. So percent of minor losses would be equal to 23.64%.